sponsored by Air Health Sky. Shipping currently accounts for almost 3% of global carbon emissions. But in order to hit the global net zero targets by 2050, solutions like biofuels, green and blue hydrogen, as well as ammonia have all been held up as alternatives to fossil fuels that we can use in ships. But what if we could go back to the early stages of shipping, where the wind was used for sailing, but using current and upcoming technology? Could wind blow past biofuels and hydrogen as the best pathway to decarbonize shipping? I'm Matt Ferrell. Welcome to Undecided. Industries around the globe have been developing, improving, and changing to green technologies with the aim to neutralize carbon emissions in the next few decades. One of the more challenging ones, though, is the shipping industry, which accounts for about 2.5% of the total carbon emissions in the world, releasing 940 million tons of CO2 to the atmosphere every single year. That shouldn't be a shock given how dependent shipping is on heavy fuel oil, and combined with the fact that container ships carry more than 80% of world trade today. The current pandemic-related container ship backups in ports around the world isn't helping. Now, currently there are about 5,000 container ships sailing on our seas every single day, and about 90% of these are powered by heavy fuel oil. A large ship can release more than 5,000 tons of sulfur oxide pollution each year, which is dangerous for the environment and for people. But before diving into how wind may help to decarbonize the shipping industry, how did we reach this point? The history of shipping and boats goes back to 4000 BC in Egypt. The Nile River was vital for the survival of the Egyptian communities and was largely used for transportation. In the 15th century, Spain and Portugal started to build carracks, which were large sailing ships that were used for expeditions. In fact, it was a carrack that first sailed around the world from 1519 to 1522. Ship improvements extended through the 19th century, when a bulkier but also faster ship design came up, the clippers. Tea clippers, which were used to carry, you probably guessed it, fresh tea, could reach a top speed of about 20 knots or about 23 miles per hour in favorable wind conditions. And a fun side note, that's faster than today's cargo ships. And the Industrial Revolution brought improvements to many sectors, including shipping. Steamships were very popular, but they weren't good options for cargo transport because the fuel, which was coal, and the engine took up way too much space. In the 1950s, oil started to be used, which reduced the size of the fuel tanks and opened up more space for cargo. And since then, the use of this cheap but dirty fuel is where the environmental issues related to shipping began to increase, and it hasn't been easy to clean it up. If we zoom out to today, we start to see alternatives to heavy fuel oil that have popped up to make ships greener. Things like hydrogen, ammonia, and biofuels. But is that really the best solution? What about taking a page from the past with good old wind? Remember that clipper ships were actually faster than today's cargo ships, and mix that with the technology and know-how available today. When it comes to wind power, we usually think of three-bladed turbines dotting the horizon or giant sails on ships. But today there are several other methods, as I explored in my solid-state wind energy video, and for shipping, it's no different. The first wind propulsion technology that's been considered for ships is rotor sails. They're also known as Flettner rotors, which are vertical rotating cylinders invented by the Finnish engineer Sigurd Savonius at the beginning of the 20th century. But they were named after Anton Flettner, a German aviation engineer who sailed a rotor ship prototype in 1926. Rotor sails harness wind power through the Magnus effect. And according to this fluid dynamics principle, when the wind pushes the rotating cylinder rotor in a perpendicular direction, it generates a force in a right angle, or 90 degrees to the flow stream. When the wind is flowing laterally across the ship's deck, perpendicular to the direction the ship is moving, the rotation speeds up one side of the cylinder while slowing down the other one. This creates lift or thrust in the same direction the ship is traveling, propelling it forwards. The Magnus effect explains why soccer players can bend a soccer ball's path as well. When the player kicks the ball off center, the ball spins. And during the flight, as the ball spins, friction between the ball and the air causes the air to react to the direction of the spin. For example, if the player kicks the ball right of center, it spins counterclockwise, and the Magnus force acts left, so the ball curves to the left. Small motors located in the ship's hull power the rotor sails, and as they rotate, horizontal thrust is generated to push the ship forward. If the wind changes direction and hits the rotors in the opposite direction to their rotation, the ship reverses. But to avoid issues and make sure things are running smoothly, there's a real-time control and monitoring system that's constantly measuring the conditions and adjusting the rotors. A system like this isn't meant to completely replace the need for fuel, but to augment it. The vessels still have engines and standard propulsion, kind of like hybrid cars. The big gain here is reduced fuel use, which can work for anything from passenger ships to bulk carriers. Now, the system isn't without some downsides, though. Wind can blow from all directions, and even highly tuned systems may not provide constant power and thrust, which would affect the fuel efficiency gains. Large and high rotor sails need to be used in order to move a large ship, so the use of this greener technology reduces space that could be used for cargo. And there's another wind power technology that's been catching the eye of freight shipping companies, but before I get to that, I'd like to thank Air Health for sponsoring today's video. The drive to decarbonize shipping to help clean up pollutants in the air ties back to indoor air quality too, but it isn't something that most people think of. When you consider that Americans spend about 90% of our time indoors, and pollutants are usually 2 to 5 times higher indoors than outdoors, it's a little disturbing. And I'm a lifelong allergy sufferer with pets, and I also have asthma. So I've used countless HEPA filters over the years. AirHealth's Sky portable air purifier has really impressed me. This thing is whisper quiet at just over 32 decibels. But what sets Sky apart is the combination of HEPA filtration with their patented ProCell technology for chemical reduction, and UV light to help neutralize bacteria, viruses, mold, and fungi. It's not just filtering the air, but actually cleaning and purifying it. It can move 420 cubic feet of air per minute, which covers over 1,200 square feet worth of your home. But the icing on the cake is that it's also smart. Its onboard air quality sensors automatically adjust the fan speed based on how dirty the air is. And the AirHealth app makes it easy to adjust from anywhere, as well as tracking your home's air quality. If you'd like to get AirHealth Sky for your home, check out the link in the description. And thanks to AirHealth and to all of you for supporting the channel. So another wind power technology that's been catching the eyes of freight shipping companies is wing sails, which is based on the same aerodynamic principles as airplane wings. Compared to traditional sails, wing sails have an airfoil shape which provides more lift and a better lift to drag ratio. In an airplane, for example, lift and drag are crucial for an airplane's takeoff, cruising, and landing. The asymmetrical wing shape causes a difference in air velocity around it, forcing air to move faster across the top of the wing and making it lift up. Bringing this concept to a ship, wing sails can improve the aerodynamic performance in a similar way, reducing drag and creating more forward thrust to move the vessel. And to do that, there are 3 things to keep in mind. First is that drag is the force that's contrary to the movement direction. Second is that lift is the force that acts at a right angle to the direction of drag. And the third is that thrust is the force needed to overcome the drag to generate the lift force. Now, similar to rotor sails, several factors like wind speed, and ship type have to be taken into consideration with wing sail technology. And a lot of planning and wind analysis needs to be performed so that everything can come together and work well. No power is needed to produce the lift, making this technology very efficient when sailing upwind. Pro of this tech is that wing sails can be operated at a small angle towards the apparent wind, which is the wind that you feel as you sail, so that these sails can harness the wind basically all the time. However, similar to rotor sails, these airfoils take space that can be used for cargo. On the other hand, while Flettner rotors have to be laid down while the ship passes under a bridge, taking up a lot of space, some airfoil technologies can be retracted. There are several companies trying to bring these technologies to market, like the London-based company Nimoy, which is based on rotor sails technology. They build the rotor using lightweight composite materials and a tower made of steel. By using these components, their system is typically less than 0.1% of the ship's dead weight. And Nimoy's rotors can be moved or folded to the deck so that they don't impact the cargo operations. Regarding fuel savings for capsized bulk carriers that carry about 180,000 deadweight tonnage, Nimoy estimates that when sailing a route from San Francisco to Shanghai and back, a 21.9% fuel and emission reduction can be achieved. More specifically, 1,413 tons of fuel could be saved for this one ship every year. One project the company delivered in 2018 involved a 64,000 deadweight tonnage geared Ultramax bulk carrier in which 4 rotor sails were installed. Something interesting to highlight is that the equipment installation took less than 2 hours per unit. Until last year, the ship sailed for 518 days, 174,000 nautical miles, and visited 50 ports. All in, the savings estimate with fuel and carbon emissions is 12.5%, or 73 tons of fuel. Now, how does that work out for cost savings? Well, another company that's also building out Flettner rotors is Norsepower. A study published in the Environmental Science and Pollution Research Journal developed a case study for a carrier sailing in a route from Egypt to France with 4 Flettner rotors from Norsepower, which is about $750,000 per rotor. The study showed an average fuel savings of 1,693 tons a year, or about 22% savings. By the end of the project's lifetime, the annual fuel savings could reach $1.3 million. The payback period ranged from 6 to 8 years, depending on fuel prices, and the levelized cost of energy after 8 years was about 5 cents per kilowatt hour. Now, jumping over to wing sails, this technology is still at the early design stages, but the company Oceanbird is trying to bring it to market. The 80-meter high wing sails are supposed to lower carbon emissions by 90%, which is kind of hard to believe. For now, they've built a 7-meter scale ship to pull information together and improve its functionality. The company aims to deliver their first vessel in 2024, so we're still a little ways off for that. But Bar Technologies from the UK is also developing wing sails for shipping. They've signed a contract with the agribusiness giant Cargill and are aiming to have their first vessels in the water by 2022. Now, while hybrid wind power systems look promising, they still are in the pilot stages, which means we can't rely on them as our only path forward. Another area that's getting a lot of funding and attention are alternate fuels like ammonia and biofuels. Methanol has also been considered, but it's only green if it's made from biomass gasification or renewable electricity and captured carbon dioxide. Unfortunately, most methanol produced today is derived from fossil fuels. The same can be said of ammonia, which is currently made from natural gas. But green ammonia can be produced using hydrogen from water electrolysis and nitrogen separated from the air, all using renewable energy. So there is a potential path for cleaner fuel production there. Now, the shipping industry giant Maersk, for example, invested $1.4 billion on ships that can run on carbon-neutral methanol. The ships will be able to transport 16,000 containers. For that project, Denmark's European Energy and its subsidiary Reintegrate would produce 10,000 metric tons of green e-methanol per year to be used in those ships. And according to Maersk's head of decarbonization, the ships would start operating in early 2024. Ammonia, which is still a recent alternative, is also at the early design stages. South Korea's Hyundai Heavy Industries, for example, has approval in principle for a 227-meter long vessel running on ammonia that will also be used to carry ammonia. Wärtsilä is another company betting on hydrogen and ammonia as a fuel for shipping. The company expects to have an engine and plant concept for pure hydrogen operation ready by 2025, and an engine running on ammonia blend this year. Even though we can see progress in green technologies for shipping, its low carbon future is still growing at a slow pace. Wind power technologies are at the early stages, mainly wing sails, so more testing and design improvements are crucial to verify the viability, although the results are promising for rotor sails too. In a similar fashion, ammonia fuel cells and green methanol engines are still in the early development stages for ships, with tests expected to run over the next few years. We've got a long way to go, but there is movement happening. But what do you think? Do you think that looking into wind technologies like these is the way to go? Are there any other technologies worth looking into? Jump in the comments and let me know. And if you like the animations illustrating the Magnus effect in this video, I strongly recommend checking out the animator Sergey Sorokin at sergeyeffects.com. He's so good at conveying complex ideas around scientific principles on products just like this. And he's also really great to work with. And thanks as always to all of my patrons, and a big welcome to new producer Bill Nussey. Your support really helps with producing these videos. Speaking of which, if you like this video, be sure to check out one of the ones I've linked to right here, and subscribe and hit that notification bell if you think I've earned it. Thanks so much for watching. I'll see you in the next one.